Hi everyone, welcome back. This is the 7th video in our video series on how to build a chess engine from scratch in the Java programming language. Until this point, we've focused on some basic concepts and how to calculate the legal moves for a knight. In this video, I want to focus on how we are going to calculate the legal moves for a bishop. And hopefully you find that it's not too difficult or different from the strategy that we've employed for calculating the legal moves for a knight. So let me bring up the Wikipedia page for the bishop piece in chess. Let me maximize this. And I want you to focus here on this diagram. So let's look at what the legal moves for a bishop consist of. Well, everybody who's played the game of chess knows that the candidate legal moves are all of the locations or the tiles that fall on the same diagonal as the diagonal that is on the tile of the bishop that we're on. So here you can see that for the bishop that's on d4, the legal moves are in 4 directions or vectors, and so let's see if we can come up with a general algorithm here. So on d4, that corresponds to what tile number? Well, let's find out. This is tile number 0, 8, 16, 24, 32, 33, 34, 35. And so let's say if we said from 35 minus 1, 2, 3, 4, 5, 6, 7. So it looks like minus 7 is that's one candidate. And then let's see what happens if I said 1, 2, 3, 4, 5, 6, 7. Oh yeah, look, that too. And 1, 2, 3, 4, 5, 6, 7. So it looks like there is a rule that corresponds with subtracting 7 from the current position over and over again to calculate the legal moves in the sort of up and right direction. So let's see if we can continue expanding on that rule. What if we said instead of minus 7, minus 9? Well, that would land us here. So from our current location, 35 minus 9 lands us here. And let's try applying that rule again. Minus 1, 2, 3, 4, 5, 6, 7, 8, 9. What do you know? That looks to minus 9 and minus 7 look like they cover the north diagonals in the left and right direction for this black bishop here located on d4. What about in the positive direction? 35 plus 1, 2, 3, 4, 5, 6, 7 in the positive direction. 1, 2, 3, 4, 5, 6, 7. Yep. And 7 plus 2 is 9. So that would land us here. And let's apply that rule again. Positive 1, 2, 3, 4, 5, 6, 7, 8, 9. Yep. So it looks like the legal move, the vectors are minus 9, minus 7, positive 7, and positive 9. Now, I can tell you from having worked this out already that there are exceptions to the rule, but let's see if we can start fleshing out the algorithm knowing what we know. So I'll come here and I'm going to create a new Java class, call it bishop. I'm going to say bishop extends piece. Yep. And so let's implement the methods. And let's create constructor matching super. Okay, great. And so let's start by saying, final list of legal moves. Let's see, what is this complaining about? Import the class. Right, and Now let's capture, for the knight, similar to the knight where we had the candidate move coordinates, here we're going to do something similar, but there's going to be a slight difference. Private final static int candidate move vector coordinates, right? Because it's really a vector of moves. So it's equal to -9, -7, 7, and 9, right? So we're going to loop through each one of those. Candidate offset in candidate move vectors. We're going to loop through each one of those. And what we'll do is we will declare an int that takes on the value of the current piece position, and we're going to say while that's a valid tile. I'm going to explain this in a second. Candidate destination coordinate plus equals current candidate destination offset. Apply the offset, and if that's a valid tile, then we want to do pretty much the same thing we did with a knight. This snippet of code. Should be exactly the same. And the only difference is that after we do this, we want to break out of the loop. So I've got some explaining to do here. Let me see if I can tidy this up a bit, and then we'll go into explanation mode. Okay. So, what's going on here? Let's clean this up. Almost there. Okay, so we're going to loop through. Let me see if I can. Let me put this side by side with the code. Right, so I want you to sort of look at the code and then look at this diagram here. We're going to loop through each one of these vectors. So we're going to go through this vector, right? That's, I think, the -9 direction. This vector, which is the -7 direction. This vector, which is the +7 direction. And this vector, which is the +9 direction. We're going to loop through each one of these coordinates. And for, let's pick the first one. For the -9, we're going to come in and we're going to say that the candidate that we want to consider starts out as our current position, right? First we want to say, is that position valid? Have we gone off the edge of the board yet? Sliding down this vector? No, we have not, right? Then apply the offset to that position. So here we'd start at this position 35, and we're going to apply -9. That'll land us right here, right? And if that's a valid position, if that is still, on the board in a legal position, then we want to check to see if that's occupied or not, just like we did with the knight, right? We want to check to see if that is not occupied, then we get a new major move, right? And if it is occupied and it's occupied by the enemy, then it's an attack move. And then after we finish doing that check, right? Actually, I think this break is in the wrong position. This break we want to put right here. And this break will indicate that, oh, look, the right. So if this is not occupied, then we want to keep sliding, right? But if it's occupied, irrespective of whether it's occupied by a friendly or enemy piece, after we're done doing that, we want to break out of the loop, right? So if there were bishop located on d4, and let's say there was an enemy knight located right here, after we, this bishop, you wouldn't want to consider a7 as a candidate legal move because obviously, the knight is a blocking piece, and that's true whether or not it's a friendly knight, right? So that's why this break exists here. So going back and explaining the loop, let's pretend we have a scenario where the tile is not occupied, so you want to keep sliding. So you'd come down here, you'd say, okay, my first offset is -9. I apply -9 to the current candidate. First I say that the current candidate coordinate is my current position, 35. And is 35 valid? Yes, it's valid. And as long as it's valid, while it's valid, apply the offset, -9, so I go up here. Is that valid? Yes, it's valid. Then get the tile. Okay, it's not occupied. Great. Add a legal move. Don't execute this else clause. And then come back all the way up here and check again. Is that a valid square? And then you'll do that again here and again here until you try to go over here and go, oh, it's no longer valid. It no longer, that offset does not fall between 0 and 63 anymore. So we don't want to consider that any longer. Okay? So hopefully that makes sense. Now there are some edge cases to consider here. And what are those edge cases? Well, let's talk about that. So if you are a bishop and you're located on the first column, then the -9 and +7 offsets fall apart. Those rules don't work. So let's test that theory. So here, let's say I was on A4 and I tried to apply the +7 rule. So I'd say 1, 2, 3, 4, 5, 6, 7. Oops, we know that's not on A4's diagonal. That's not working. And let's try applying the -9 rule. -1, 2, 3, 4, 5, 6, 7, 8, 9. Oops, that doesn't work, right? So I've already worked this out, and I encourage you to pause this video and find out where the rules fall apart. But here I'm going to go ahead and start doing that here. So private static Boolean is first column, exclusion, final in current position, final in candidate offset, return board utils dot first column. Am I on the first column? And the candidate offset is -9, or the candidate offset is +7. So that's the column exclusion rule when I'm on the first column. And let's copy that method and say is 8th column exclusion. And this rule says, am I on the 8th column, and is the candidate offset equal to -7, or the candidate offset equal to +9? Right. So those are the positions in which the rule falls apart and does not work anymore. So now all we have to do is come back here in the while loop and say if is first column exclusion, and that's going to be the candidate destination coordinate and candidate offset, or is 8th column exclusion, candidate destination coordinate, candidate offset. If that's true, then we just want to skip that. Well, we don't want to skip, I'm sorry, we want to break out. Break. And I think that's correct. And again, unit tests will help us here in the future. Once we have sort of a critical mass in our code to start developing unit tests, we'll be able to test this. But I think everybody gets the idea here. So in the next video, we will pick up where we left off and start looking at the legal moves for a rook, which will be even closer to a bishop than a bishop was to a knight. Okay.